hope you all are awake. Okay, so I'm going to talk about optimization and computational evaluation of mechanical juice extraction from cassava leaves. It's a continuity of some previous talks which were discussed in the morning, like sustainability, food security. So this is also one of our objective to fulfill during this study, and we tried, okay, why not to use this resource. So few words about cassava. It's widely grown in the tropical and subtropical countries. 226 million tons is the estimated production in 2006, grown in 105 countries, ranked fourth most important crop, staple food for 1 billion people, mainly grown for starchy roots, but stems, leaves, and petioles can also be used as a food. And Congolese call leaves as a old man's meat, but mostly is left in the field without further attention. So it's a present status. Very nice work. They is represented like the dense here, high consumption here in Africa, and the more moderate consumption, and just to give an impression about the consumption of leaves in Africa. Not only in Africa, but some other countries like Brazil, Indonesia, Malaysia, Philippines, Sri Lanka, and in different countries people are already consuming leaves and have different names. I traveled different parts of the countries, different parts of the world, and I inquired about the leaves, and people were very happy to talk about it. Last month I was in Malaysia, and I asked people, okay, so are you already eating it? And they were very happy. But there is lack of research work on this important area. So when we talk about the nutritional aspect, it has high protein, vitamins, essential amino acid profiles similar to Hex-N, greater than spinach leaves, soybean, oat, rice grain, high essential amino acids as compared to the FAO recommendations, but it also has anti-nutrients which reduce nutrient bioavailability. It has phytate, trypsin inhibitor, fiber, nitrate, so it's again a long list. And these anti-nutrients vary depending upon the maturity, climate condition, and variety of cassava. So not only anti-nutrients, but it also has toxic aspects, cyanogenic glycosides, which is most toxic compound. It's available in 3 forms, mainly linamarin, and when the amount is more than 100 ppm, it's considered highly poisonous. People are consuming it, but not properly processed. They have traditional processing methods, and not instead of having a benefit from these, all the protein, rich protein, and all the nutrients, but with due to the presence of these anti-nutrients and toxic aspects, they are having problem. So according to FAO, it should WHO, it should be less than 10 ppm. Young leaves are newly germinated leaves. They have high cyanogens. their leaves are more toxic than the roots, so 5 to 20 times more toxic. But on the other hand, it also has 200 times more lineamirase, which can detoxify the lineamarine present in the leaves. So the point is also the sustainable future protein. Some people already talk about sustainability and sustainable future protein. So it's a problem. It's a serious problem, and cassava leaves may be and can reduce this problem if we are able to properly utilize this. Because there was also a discussion that the production should be from the same place, not should be produced somewhere else. And so it's there, like when I think now different speaker already mentioned that mainly around 800 million people who are hungry, and mostly is in the African countries, and they are already producing it, so why not to use this? So, but direct consumption has disadvantages, and these direct consumption is limited because of the high fiber content, toxic substances, anti-nutritional factors, low digestibility, of course bad taste. It can be possible to use as a protein source if we are able to process these leaves or to extract the protein. So we adopt a simple approach, like use a oil press to press the leaves, and try to optimize the operational parameters. First of all, screw press speed and the nozzle diameter speed was changed from 18, 28 and 40, and the different nozzle diameters, where it is. So different, you can see here 2 millimeter, 4 millimeter and 6 millimeter. These nozzle diameters we selected based on our preliminary trials. We also put sensors to check the temperature variation during the pressing. So like for press cylinder, juice coming out, and the press head. So this is how we obtain the juice, cassava leaf juice, and the pellets with different nozzle size. We got very nice cassava leaves noodles. Of course, we still we are just in the beginning, and we have to evaluate the quality. So this is how the juice look like, and after, when we keep in the fridge overnight, it also gets sedimented. So for the optimization, we found maximum efficiency up to 90% with nozzle of diameter 4 and screw speed 18. You can see here the red area, and this was the trend of the temperature, like the maximum temperature of the press head was increased more than 40 but below 50, and the juice was lower than somehow 30, and also the cylinder also. So this temperature variation is with nozzle size 4 millimeter, and when we change the nozzle size, then the temperature is reduced, and again with the bigger nozzle size it's again reduced, but anyhow it's not exceeding 50. So we also check the throughput, like how much material we can pass through and we can press. So both nozzle 4 and 5 were more or less the same. So this was the simulation of velocity and flow trajectory to see the effect how under the optimized conditions. So this shows the trajectory and the velocity. And the computational pressure we also estimated and calculated by using the software. So left side is the pressure. So this is pressure in bar, and the shear rate also under the optimum conditions. So the conclusion, we were able to press cassava leaves while optimizing the screw press speed and the nozzle diameter. Low motor speed and the low nozzle diameter leads to higher extraction efficiency, and the temperature was lower in the press head, so it may be it might not have a negative effect on the protein. Still, we have to analyze the quality. The flow simulation, we consider cassava leaves as a non-Newtonian fluid, which seems suitable for simulating, and high rotational speed it doesn't help to increase the throughput, but it just increases the velocity. With this information, we can develop a proper press for exactly pressing the cassava leaves. So that's all. I would like to acknowledge the funding agency, and thanks for your attention.
Thank you very much. A question?
Look, I will.
Okay.
This is extract cassava. It's like maybe episode drug. It's like cocaine from some extract or some cannabinoids from this grass. So you make some extraction for this cassava, and you extract some active, physiologically active compounds. But maybe it's episode drug. Maybe it will be forbidden for use it after 1 year.
Is what?
Episode drug. It's like narcotics.
Narcotics?
Yeah. Why not? It looks like narcotics. Exactly. It's alkaloids from some growing.
Yeah, but we are going to detoxify it, and in our other study we already detoxified. And right now there are so many studies, people are already consuming it. Of course, it's still a question how they are processing, and also there are studies about for using leaves as a animal feed. So you can find so many publications about that. So this is one step. So but we are going further, like to why not to use it properly as a food? First of all, to extract it, and in parallel we are also trying to detoxify the leaves, and one of my master student already did the job, and we got very optimistic results.
My question.
From my point of view,
Yes.
all narcotics usually use it like additive to food to reduce your weight. It's the best compound, like opiates or another, like a cassava extract. It also could be used for reduce body weight.
Yes, but it was before that process.
Yes.
My question is, if we're going to do toxification or toxify the extract, you think FDA can approve this already as a food ingredient or food protein or?
So first of all, I think just to satisfy
Yeah.
that question, could you imagine that we are having the leaves available in Germany?
As
For-
extract or
no,
as
no, no,
Oh.
the leaves, frozen leaves available for people to eat, and people are eating it.
But this is, as you mentioned, already it has some narcotic properties.
Yes.
So that means it's not approved by
But
any legal
yeah, but
organization or
yes, but
FDA
it
or.
it's
Yeah.
available. So this is one thing. So now I come to your question. So
Yeah. But about FDA, for example, food.
Yeah.
Is this acceptable by FDA to be to use a protein from this extract already as a food ingredient? Or
first of all, we are going to extract, and then of course we will check the quality, and then it comes later. Either it's acceptable or not. Even GMO is also not acceptable in Europe. It's acceptable everywhere.
can you remove this alkaloid 100%, or there is limits, a threshold that
Of
mean
course,
you will?
I started 2-3 years ago working on the cassava leaves, and I'm very optimistic, and we got very good results. That's what I mentioned, like even just with a small study, we are able to detoxify properly. So one after the other. So even when you talk about rapeseed, so in the beginning, who was thinking about using rapeseed as a protein source? So you have to begin from one point to the next. So this is just the beginning. Yeah.
I want to add that it's not even all species that are highly toxic. There are some species that the toxin is very minimal. In Nigeria, we use it to cook soups, but we know the varieties that we use. It's not all varieties. The native know the varieties that they use in cooking, and then it's harmless to them.
So one more thing, this toxic compound through which I just horrified you all is it's not only in cassava leaves, it's also in almond. But it's a combination what you eat. Like it's not only like even we you know bitter almond.
Yeah.
It has the same compound. The point is how you consume it. Even some because you can also find on a review article. I'm not marketing my review article, but just I compiled all the information. So this compound is not not only in cassava leaves, it's also in some other food crops. The point is, even for these cassava leaves, there were some studies that in one part people were not having a negative effect or no health issues. In some parts, people having serious health issues. Why? Because of the diet. Because what else you eat? If you are only depending on the leaves, on the cassava leaves, and you are just putting this toxic compound in your body, then and for example, if you eat it time to time or make a good combination, if you look at this, maybe you didn't notice this. Oh, maybe this table. This is the table which I prepared on my own, based on the literature, whatever I found. So it's already used in Brazil as food supplement to combat malnutrition. I did not emphasize more on this table because just to conclude my presentation quickly. So that was the reason. So multimistora was the name which they name it, and like see, and people have why people name these dishes means it's famous, and that's why they name it. And I spent a lot of time to prepare this table. because I've tried to find, okay, what is the name of this dish in Malaysia. Maybe people from Malaysia, they can understand the name. And yeah, so it's even from Indonesia, I spoke with people. So when I was preparing this table, I was continuously communicating. Is it really happening, or is just someone already just put it? And in where it is there, yeah, this one. So
Thank you very much.